Okay, for problem 51, we have this pair of linear inequalities to graph. This system, the solution will be the intersection of the two separate solution sets, the overlap. So let's start with the first line. We'll need to find 2 points on this line. So let's just find a couple of quick points. If x is 0, then y is 3. And if x is 3, then y is 0 for that first. So there's the 2 points on that. And let's graph it. So it's 3, 3, 1, 2, 3. The x-intercept is 3 and the y-intercept is at 3. So this line, which will be a dashed line since it's not or equal to, or not including the points on the line. So this line looks like that. We have to decide which side to shade. We can ask, is the origin shaded? And we can answer that question by substituting 0 for x and y. So is 0 less than 3 minus 0? Is 0 bigger than 3, I mean? So that's the answer to that is no, 0 is not bigger than 3. So the origin is not shaded. So it's the opposite side of the line that's shaded. It's this side that's shaded. And now we have to plot the second line. Y is less than x plus 3. So let's do that one now. And we need a couple of x values for that one. For this one too, if x is 0, y is 3. But now if x is negative 3, x has to be negative 3 for y to equal 0 here. So 0, 3 is this same y-intercept as the first line. And negative 3 comma 0 is right here at negative 3. There's an x-intercept. So this line, also a dashed line because it doesn't have or equal to, goes through these 2 points. And we have to decide which side of that line is shaded. We'll answer this. We'll ask the same question as before: is the origin shaded here? But now we'll use the second line. Is y equals 0 now, and x is equal to 0. So is 0 less than 0 plus 3? Is 0 less than 3? Yes. So the origin is on the shady side of this line. So it's shaded like this. And we're interested in the overlap. So the overlap is the region up here. It's everything between these two lines to the right as we get going. So this is the solution set to that system of linear inequalities. Now, problem number 52, we're going to do the same process. So let's do that. So once again, we need 2 points on the line. We'll start with this first line and make a little xy table. If x is 0, then 2 times 3 is 6, so y equals 3. And if y is 0, then 3 times 2 is 6. So there's 2 points on that line. 0, 3, 1, 2, 3 is the y-intercept. And 2, 0 is the x-intercept. This is a solid line because it includes the line itself, or equal to, as part of this. Which side of that line do we shade? We can ask, is the origin shaded? And the way to answer that is to take the original inequality, plug in x equals 0 and y equals 0, and see if it's true. And indeed, 0 is less than or equal to 6, yes. So the origin is shaded. So, this is the shady side of this line. And now we have to graph the second line they gave us here. So we need 2 points on that line, and we need to ask these same questions. So let's get ready for that. Now if x is 0, y is still equal to 3 here, so this has the same y-intercept as the first line. But now it's when x is negative 3, then y is 0. Negative 3 plus 3 adds up to 0. So this has a y-intercept here, and at negative 1, negative 2, negative 3. And this is a dashed line. It doesn't include the points on the line as part of the solution. So we have this line. And we ask, is the origin shaded? So now we use the line y less than x plus 3. We substitute x equals 0 and y equals 0. So we wonder, is 0 less than 0 plus 3? Is 0 less than 3? Yes. So the answer to this question is another yes. The origin is on the shady side of this second line as well. And so we graph that. That's everything on this side of this line. And you see where the overlap is. The overlap is everything in here. It includes the points on this line, but it doesn't include the points on that other line. So it's everything in here. The solution, the graph of the solution set to this system of linear inequalities.